Point 12 is on implicit relations. So if you remember when we did implicit differentiation, that's when you could not get y alone. So you had to differentiate with respect to x to both sides. So this is a very, very common free response question on the AP exam in May. They'll actually tell you what the answer is. So do you know how we've talked about where they'll force you to simplify? So they'll do this. They'll say, okay, show dy dx is 3y minus 2x over 8y minus 3x. So they can force you to simplify in a manner they want. They can do it on free response in this manner. So let's go ahead and do this. So this would be 2x. Now dx dx is 1, so we don't write that. This would be 8y dy dx. The derivative of a constant is 0. And then I'm going to treat 3x y as 3x times y. So as I do my first times the derivative of the second and so on. So this will be 3x times dy dx plus y times 3. So we're trying to get the cobwebs out from earlier this year. So what you want to do is you want to collect the dy dx terms on the left. That is typically how they do it. And then you put your other terms on the right side. Again, you collect your dy dx terms on the left, and anything without a dy dx you move to the right side. I'm going to factor out the dy dx. So when they say show, if you skip too much, you're not going to receive full credit on a free response. Then I would divide both sides by the 8y minus 3x. So there I have it. So my guess is this would probably be close to 3 points, and where I'm putting a star, those are where your point values are. Like these would be your minimum statements. All right, is this coming back to you, our implicit differentiation coming back? Okay, good. And after the quiz on Friday, I'm going to start doing this where it will be rare that you get breaks after quizzes and tests anymore. Second semester, we've got to be doing test prep. So after the quiz Friday, I created a worksheet and I went all the way back to our limits. And I remember when we did our limits, we were struggling with notation, appropriate notation. So I've created that worksheet. I think I have it open for Thursday, so if you want to get a head start on it, if you have some free time, you can do that. But I'm going to start hammering older material, and we have to remember everything for the AP exam. All right, part B. Show that there is a point P with x coordinate 3 at which the line tangent to the curve at P is horizontal. So let's play the what do I know game. What would you know if we had a horizontal tangent line? Yeah, Julia? Good job. My slope, which is dy dx, would equal 0, right? Now this is at x equals 3. So let's go to 3y minus 2x over 8y minus 3x. So like making this statement would be 1 point. You want to constantly look through your problems through the lens of a grader. A grader is looking at what do you know. You're trying to demonstrate your knowledge. So then I also know that x is 3. Now, when does a fraction equal 0? Yeah, when the numerator equals 0. So that gives me y equals 2. Now so this is the point, 3, 2, and it says show that there is a point P. That is going to be on the curve that has a horizontal tangent line. So what I've got to do now is I've got to go to the actual, let me go back up here and see it. You see where the function is? I've got to show that 3, 2 is actually on this curve. So we're going to plug it in and make sure it's on the curve. All right, it's an equal sign. Okay, so we've just shown that 3, 2 is on the curve at a point where the tangent line is horizontal. So part C, find the value of d2y over dx2, so that's the second derivative, at the point P in part B. So you want to find the second derivative at 3, 2. That's going to be your first step. So I'm going to pause and give you a head start. Go find the second derivative, then go find it at 3, 2. And then you're asked, does the curve have a local maximum, local minimum, or neither at point P? Justify your answer. All right, so go ahead and get started finding the second derivative. All right, so I'm going to look at my first derivative. dy dx was 3y minus 2x over 8y minus 3x. And so if I want to find the second derivative at a point, so I'm going to do low d high. So that's 3 dy dx minus 2 minus high d low, so that's 8 dy dx minus 3 all over low low. So you would get 1 point for just that step. And then we're going to plug in 3 comma 2. Now stop and think here a minute. 3 comma 2 is from part B, right? So what is dy dx then? 0, right? Let's don't go find it again. We just did that, right? So, we want to work smarter. So this will be 3 times 0 minus 2 minus 3 times 2 minus 2 times 3, 8 times 0 minus 3, all over 8 times 2 minus 3 times 3 squared. So I'm getting 16 minus 9, which is 7, times negative 2. 6 minus 6, isn't that just 0? So that whole thing is 0. And then that's 7 squared. So that's negative 2 sevenths. Now they asked us to do the second derivative because they were setting us up to use the second derivative test. Okay, so I'm going to change color so you can see this. Using the second derivative test, so when the second derivative test is negative, that means it's concave down. So does it have a local max or a local min? A local max. So that is pretty darn cool. All right, questions on that? So really, we've just taken prior knowledge and applied it in Chapter 5, which is really rather cool. All right, example 2. Consider the graph of 4x squared minus 4xy plus y squared plus 8x equals 12. I'm going to give you about 5 or 6 minutes. I want to give you a head start here on me. And I want you to try and do as many of the parts in example 2 that you can. You should be able to find the first derivative. Hopefully you remember how to find an equation of a tangent line. You're going to have to go find the x-intercepts first, and we know how to do that. Part C, I might have to help you with that one, and that's okay. But if you can't do C, skip it. Go to D. You know how to do an equation of a horizontal tangent line. And then E, you should be able to do that one as well. Find the coordinates of all points on the graph where the tangent line has slope 1. I do expect you might have trouble with part C, and that's okay. Hang tight, and I'll go over it. All right, I'm going to go ahead and get started. Let me do dy dx, so that's 8x minus. Now here you got to be really, really careful. You have a minus 4xy, and I know that that's a product rule. So if I'm going to subtract a product rule, I have to temporarily insert a grouping symbol while I do the product rule, okay? So that's going to go 4x times dy dx plus y times 4 plus 2y dy dx plus 8 equals 0. Okay, this is going to be the most common mistake made, is not distributing that subtraction sign across the product rule. Okay, so check it and correct it if you need to. So that'll be 8x minus 4x dy dx minus 4y. And you can't fudge it, okay? There is something called I like to call it the fudge factor. Students who don't put the parenthesis but then know what the answer is and then magically stick it in later, then they know that. If you don't have correct algebraic work, then you're not going to receive full credit even though you've got to the answer. So be careful with that. I'm going to factor out the dy dx, and I'm going to multitask here. So do you see? And I used the commutative property and switched the order. Okay, when I factored out my dy dx, I went ahead and put the 2y first. There's nothing wrong with negative 4x plus 2y. It's just typically not how we write it. Okay, usually your leading coefficient is not negative if you can avoid it. All right, now I'm going to divide both sides and get 4y minus 8x minus 8 over 2y minus 4x. Now you can divide by a common factor of 2. Now you could have divided it out up here. That would be okay if you did it up sooner. That's okay. All right, any questions on the implicit differentiation? All right, part B, find the equations of the lines tangent to the graph at its x-intercepts. Well, you need to find the x-intercepts. If you think graphically, where is an x-intercept located on a coordinate grid? Yeah, Daly? Exactly. Okay, so when you want to find an x-intercept, that's where y is 0. So I'm going to get 4x squared plus 8x equals 12. If I'm plugging that into the original equation, I'm plugging in that y is 0. I'm going to multitask. I'm going to divide by 4 and move the 12 over, okay? So I'm going to get x squared plus 2x minus 3 equals 0. So I divided by 4, and so I took the 12 divided by the 4 and brought it over. So that factors pretty simply. So I'm getting x-intercepts at x is negative 3 and x is 1. So this means I have 2 tangent lines, okay? One at x is negative 3 and one at x is 1. So I'm going to write 2 equations. So my slope is dy dx, and I want it at negative 3, 0. So that's 2 times 0 minus 4 times negative 3 minus 4 over 0 minus 2 times negative 3. So that's 4/3. So this equation would be y minus 0 equals 4/3 the quantity, x plus 3. That's absolutely fine to leave it like that, or you could tidy that one up. Then we're going to do the slope at 1, 0. So that's 2 times 0 minus 4 times 1 minus 4 over 0 minus 2 times 1. So that's negative 8 over negative 2, which is 4. So then I do y minus 0 equals 4 times x minus 1. And of course, you could always multiply it out to y equals mx plus b, but you do not have to. All right, how are we doing so far? Making sense? All right. Part C, this is the one that I think that we may have struggled with. It said write equations for the vertical tangents to this graph. All right, is there anybody who is feeling confident about this? I'll tell you the answer was x equals 3 halves. Daly, did you get it? Yes, exactly. That's awesome. That is awesome. Okay, so what we need, so if you have a vertical tangent, the slope is going to infinity or negative infinity. And so what we need is some number divided by 0. So then you're going to take that denominator, which was y minus 2x, and set it equal to 0. So y equals 2x. Okay, well, we sort of have a problem. I'm like, okay, that is not the tangent line. That's just where what y is. so watch what we can do. We can actually go back to the original equation, because a vertical tangent line is of the form x equals a number, right? Think about a vertical line. If I want a vertical tangent line, so we're going all the way back to Algebra 1. Okay, in Algebra 1, if I have x equals a number, that's a vertical line description. So watch what I'm going to do. Everywhere I see y, I'm going to plug in 2x. Then I'm going to solve this for x. So let me pause a moment and let you try this. Try and solve it for x. So I'm getting 4x squared minus 8x squared plus 4x squared plus 8x equals 12. So all those x squareds cancel, and I get x equals 3/2. And that is my vertical tangent line. Okay? So the big idea here is that if you ever want to find a vertical tangent line, that occurs where the derivative, the denominator, is 0. Okay? All right, then in part D, write equations for the horizontal tangents. Well, we would know that dy dx equals 0, and that's going to occur where the numerator is 0. So we're going to set 2y minus 4x minus 4 equals 0. And I get 2y equals 4x plus 4. So y equals 2x plus 2. Well, this needs to be a horizontal tangent is y equals a number. And I can find the location of this. So I'm going to go back to that equation, and I'm going to plug in and find the x-coordinate. I guess you could solve for x and go the other route. But I'm going to find the location, the x-coordinate, on the curve, and then plug it into this equation here. So I get 4x squared minus 8x squared minus 8x. 4x squared plus 8x plus 4 plus 8x equals 12. Oh, that's lovely. The x squareds cancel. One pair of 8x's cancel. I get 8x equals 8, so x is 1. So then that's going to be y equals 2 times 1 plus 2. So my horizontal tangent is y equals 4 at the point 1, 4. That's where it's going to have a horizontal tangent line. All right, letter E. Find the coordinates of all points on the graph where the tangent line has slope equal to 1. So, if you want the slope to equal 1, we're going to set 1 equal So 2y minus 4x minus 4 over y minus 2x. You could make this a proportion and cross multiply. So I get y equals 2x plus 4, and I've got to go plug that into the equation. So I'll give you a head start on me. So go ahead and solve that for x, and then you'll plug it back in to get the y coordinate. All right, so the x squared's canceled, the 16x is canceled, and I got 8x equals negative 4, so x is negative 1/2. So are you getting y equals 3? So the point was negative 1/2 comma 3. Let's go to Desmos and take a look at this and see if we can't like make a connection graphically to what's going on. Everybody got that? No, because that is the derivative. Yeah. All right, let me see if I can't pull up Desmos. Let's see what will happen if this will graph it this way. I don't know if it will. We're going to just give it a whirl. Oh, it does. Oh, how cool. Okay, that's like freaky weird. Okay. Yeah, like really weird. Like struggling to get back to where I was. Oh, there we go. Okay. So let's kind of talk about this. At x equals 1.5. Oh, that's kind of cool. Do you see how you could, in fact, get a vertical tangent line at x is 1.5, and then at x is 1, yeah, part D, if you look at part D, at x is 1, there's our horizontal tangent line. Then in part B, at x is negative 3, we just came up with our equation of a tangent line. And that does look like it has a slope of about 4/3. That's kind of cool. And then at x is 1, on this curve, yeah, that's still positive. So, over at x is 1. 4x minus 4. Yeah, that's kind of cool, just to see what what it looks like from there. I just feel like our brains are pretty full right now, so we're gonna stop here. I'll unlock the homework, but then we're gonna finish this free response question tomorrow. I think our brains need a little bit of a break because this was some heavy duty content.